Good evening, everyone. Welcome to the webinar on Spring Cloud Contract. I'm Sashi. I will be moderating this webinar today evening. First, a quick introduction to start off for those of you who are joining our webinars for the first time. At start off, we seek to match people with work more efficiently. That's the broad vision statement. We're currently focusing on creating a vibrant community of Java developers, where you could find interesting career opportunities, engaging resources to learn new things, and the opportunity to network with experts and seek their help. The main purpose of our webinars is to help developers learn new frameworks and tools that make them more productive at work. We bring great speakers from the tech world to talk about new tools, languages, and frameworks. So for today's webinar, we have a great speaker, Olga Maściszek. She joins us from Warsaw, Poland. Brief introduction about Olga. Olga is a Java and Groovy developer. She's interested in microservices, resilient architecture, and cloud solutions. She works in the Spring Cloud team at Pivotal, where she participates in the development of exciting projects, including Spring Cloud Contract, which is the topic of today's webinar, Spring Cloud Netflix, and Spring Cloud Gateway. She has strong experience in developing both enterprise-level applications as well as solutions and tools aimed at improving the software delivery process and creating resilient microservice architectures, including consumer-driven contracts and Jenkins job DSL-based tools. More interestingly, Olga is an avid open source contributor, including to the Spring Cloud Contract team. She has been associated with that team from its very beginnings, and she has worked on deployment pipeline projects that led to the inception of Spring Cloud pipelines. Olga, has a very popular presence on the internet. She has a widely followed Twitter profile, and she talks regularly at community events and conferences on these topics. Olga, it's a pleasure to have you on the webinar. Thanks for taking the time out.
Thank you.
Yeah, so I'll just make one quick introduction to the session and then get out of the way.
Sure.
Okay, yeah. So like we all know, a majority of a backend developers' time goes into building APIs. As programmers, we try to kind of extract every inch of performance improvement from the APIs, but it is also important to pay attention to the stability, the resilience, and so those aspects. So today's session is focused on helping you build a good understanding of the Spring Cloud Contract Verifier. So that's a tool that enables consumer-driven contract development. And it is shipped with the contract definition language, the DSL, written in Groovy or YAML. And it is an umbrella project holding solutions that help users in successfully implementing the consumer-driven contracts approach to development. So the session will take about 50-55 minutes, and we have like an additional 5-10 minutes at the end for Q&A. So if you have any questions, feel free to ask them in the chat, and we'll have Olga answer them for you. So with that, I request Olga to kind of begin the webinar.
Sure. Let me share my screen with you. Hi. So hello, everyone. Thanks for coming. So I do work at the Spring Cloud team. Now it is in VMware, and I mainly work on Spring Cloud Load Balancer, but I have also contributed quite a lot to Spring Cloud Contract and other Spring Cloud projects. You can find my GitHub and Twitter accounts under these links. So without further ado, let's just dive into the presentation. What will we be trying to improve as the topic of this presentation? So I am not going to tell you that I'm going to solve all your problems. I do not have a silver bullet, or as we say in Polish, a golden hammer. So I cannot bring you a tool that will solve all your problems. However, I will try to solve 2 of them during this presentation. The first problem that I will be trying to help you solve is faster tests. So not that long ago, we all had only monolithic systems where we had everything in a single executable jar. And then we also wrote a lot of end-to-end tests. It was very easy to test the monolith on the highest level. So we did that, and we wrote end-to-end tests extensively. In fact, I have seen projects that were only tested with end-to-end tests. That was not good, but it did happen a lot. And we also got used to very long deployment pipelines. And I guess many of you have probably seen deployment pipelines where end-to-end tests alone took 2 hours to execute and then failed at the very last stage. And usually the reason was that something has changed in the test environments and in how fast things were happening, or someone has modified a string. So not a very effective approach. In fact, with time, we got so used to long-lasting pipelines and tests that someone has even created a We Need Beer plugin for Jenkins. And of course, it is entirely possible to write end-to-end tests which are good and avoid many of these caveats. However, if we solely or mainly rely on these long-taking UI-level end-to-end tests, we will get to what Venkat Subramaniam calls the pathway to hell automation. So, as we know, these end-to-end tests had many issues. They were slow, they were unstable, and they relied on collaborators. So we had to have other applications and the data sources that our tests used running usually. However, with all that being said, we could mostly trust these tests. There is a reason why there were so many of them. This is because they were directly simulating actual user-triggered processes, and we felt very reliable. We felt that they were very reliable. They were comprehensive, they verified borders, they verified complex scenarios, and simulated the user behavior. But things started to change. And there was a time some years ago when you could see the switch. Suddenly, whenever you went to any conference, what would happen is you would only hear about microservices. Every talk would be about microservices. And what happened in the industry in general is that we started to move more and more towards distributed architectures. This is not to say that these architectures are intrinsically better and that they suit any type of applications, but in today's world, we've just seen more and more scenarios where this makes sense and where the distributed systems are the best approach. So we needed to start doing differently, write code differently, but also test differently. As we divided our code base into smaller chunks, we were able now to develop faster, add new changes and features very fast. But then, of course, we also wanted to test it fast. We don't want to add our feature very fast and then have 2 hours running tests. Also, we have decoupled deployment. So it has become a major concern to have every service not only to be developed separately, but also to be able to deploy it and test it separately in isolation from other components. And this is extremely important to decouple the deployment process. In fact, Sam Newman, in his book Microservices, argues that if you do not decouple your deployment and you do not have independent deployment for your microservices, what you end up with is a distributed monolith rather than actual microservice-based system. And that is a very big anti-pattern. So we need to deploy them separately, and that means we also need to be able to test them separately. And we have also moved with this agile development to more agile teams and to agile releases. We want to have Scrum, short release cycles, continuous deployment, and continuous delivery. Also, one other thing that has changed is the paradigm shift from fail-safe to safe-to-fail. For a very long time as an industry, we thought that it was actually possible to create applications and systems that would not fail. And we thought that if we spent 2 months collecting the requirements and writing 200 pages documentation, and then developing it for some long time to get this whole chunk developed together, and then running automated tests, and then having a team of manual testers verified, and then another team of manual testers from a different company, and then we deploy all of this to production, it will be safe, it will not fail. And as time has passed, we have realized as an industry, and it's actually quite funny that we took so much time to realize, but finally we did. We understood that our code and our applications will always fail in production. In fact, Susan Fowler writes in Production-Ready Microservices that if there is something that can fail in the application, in the system, it definitely will. So instead of trying to prevent things from failing, we are trying to make it safe to fail. What does it mean? It means appropriate monitoring and logging of our applications so that we can find the issue very quickly, and then very short release cycles, so we can find very easily which change has introduced the bug, because in every release, we just only release a small number of changes. And then what we also need to do is to be able to ship the fix very quickly. So again, we need to have fast pipelines and fast tests. And with this, we have started this shift to the left approach. So if you look at the tests, you have these obviously unit tests, component tests, integration tests, end-to-end tests, and so on. So we used to rely heavily on this right side, on the end-to-end test. But as we shift to better practices, we want to have a lot of unit tests and then some less integration tests and very little end-to-end tests just to verify our key scenarios. And what has also happened is we need to use stubs, because if we now have this microservice-based system, distributed system instead of monolith, there is a lot of network communication going on. So if we want tests that will be fast, we need to stop some of this communication. And how do we do it then? There are several tools, such as WireMock, that allow you to create stubs. And when you want to write an integration test that will work in an independent pipeline, so in a decoupled pipeline, and will not have to communicate with other applications or data sources, and will not have to rely heavily on any network communication because that is slow, what you can do is create stubs. So for example, with WireMock, a stub will look somehow like this. You will be able to define that when you send a request with a certain method, here get, at certain endpoint, you will receive a response. And then you define the status of this response, you can define the body, you can define the headers, and so on. And WireMock is very flexible. So this is a very simple scenario, but you can also use regex pattern matching and handle much more complex scenarios. And then using WireMock, so WireMock is an in-memory HTTP server. It will load these stub definitions that you will have in a certain directory in your project. And then whenever your tests will make requests that match these definitions, they will be getting responses as defined. It is fairly straightforward. WireMock is a very powerful tool. It allows you to do a lot of stuff. And then you can use it, so you will start doing it and you will start stubbing. And we have seen a lot of systems that moved to microservices and started relying very heavily on stubbing. And your tests pass, you are happy, you can go to production. However, what very often happens then is that unfortunately, a lot of times things will fail. And why is this? So the main problem with this approach is that the stubs are created usually by the same people that are creating the integration tests. So by the team that is responsible for the apps that consumes a REST API. And there might be another team completely working on the actual app that has this REST API. So somebody is creating the test, but they're also stubbing another application, and they're assuming, oh, that application behaves that way. I'm going to define it here, and then I will be sure my application communicates with that other application. However, humans are not reliable. Human communication is not very reliable. So what can happen is we even meet the other team and they tell us that they will have an endpoint X in their application. So we create our stubs and we put endpoint X, and then we test our application against this and everything works fine. But the other team has forgotten about it and ends up putting endpoint Y. Or they told us there would be endpoint Y, and we made a mistake and put endpoint X in our stubs. Or there was an endpoint X, but someone had a bad day and decided to change it without telling anyone. So if you don't have a process, if you don't have automation in place to prevent it, your stubs are not any source of, are not going to reflect in any way the other application. Your stubs will be more of a wishful thinking scenario. There will be absolutely no guarantee that your stubs for your integration tests reflect how the other application is behaving. And similarly with messaging, there are many tools and frameworks that will allow you to stub the messaging routes for your integration tests. So for an integration test, for example, you can pretend that you are getting a certain message to a topic with a name or a channel, and then that you can deserialize it to certain POJO. Again, the problem here is that if you stub it and you are on the team that is writing the test, so consuming these messages, you might not know that something has changed in the other application that you are stubbing. So the topic, for example, might be different where the messages are being sent. And I have seen this happen in a project and things failing. Happily, that was in a staging environment, not in production. But yeah, I'm sure that it happens to many more projects, not just that one. And also, when we serialize and deserialize the data, for example, in our stubbed communication, we can be using a class that has a field ID, while in reality, the other application puts a field product ID to create that message. And everything will fail if we rely on these stubs. So stubs alone are very fast. They allow you to test without network communication. But if you are testing just against stubs that you created, they do not guarantee anything. It is more of a wishful thinking. So they have lots of advantages because they are fast, they are stable, they are independent, but such tests can be also very unreliable. So what could you possibly do to retain these advantages of fast and independent and stable tests, but at the same time make them actually work? So make them verify something for sure. This is something that we will be talking about as we will see the tool. And this is one of the problems that I would like to propose a solution to. But first, I'm going to introduce the second problem. So how to create better APIs. Again, going back to our monolith, before we didn't need to have a whole lot of APIs, and we didn't have a whole lot of network communication. We usually just had a server, maybe with some limited client apps that we didn't care all too much about. The APIs were very limited. often these were some kind of public or external APIs. They were very stable. They were not something that you would change. Generally, you would just have one version that would work one way, and any changes would only be found in any future versions. And also, the communication for internal application was very limited. But as we change to our distributed architectures again, network communication has suddenly become the first-class citizen in our application. So suddenly, we had multiple instances of many services communicating with each other over the network. And that meant numerous and fast-growing APIs, and even APIs that changed, because for internal APIs, we did not often feel that we had to adhere to the rules that were there for public APIs. So as the APIs and the communication within our system was part of the functionality, we had to be able to change it, and we started treating it very differently. It was not this fixed and stable thing anymore. But this has also introduced the possibility to collaborate between the producers of the API and the consumers of the API. And some of you might be thinking, why would we want to do this as a producer team to collaborate with the consumer team? And this is something we will come back in the future to in a moment. But first, let's talk about what these terms mean so that everybody is on the same page. So the producer for this presentation will be the application that either has an HTTP API, so exposes endpoints, or sends messages. And the consumer will be beside the application that is sending requests to that HTTP API or is listening to messages. Obviously, a producer for one application can be a consumer for another, or even for each other. For different scenarios, these roles can shift. So why would we want to have these two parts collaborate? Some of you might think that, we are creating this app that has this REST API, and this is our app. We write it, we know the functionality, we know best what the API should look. We just created the way we like. Why would we want to engage any other teams that are communicating with our application to work on this API together? But are we really the side that knows best what this API should look like? Maybe various times in your career, you have seen code that was clearly written with the idea in mind that this code was hard to write, it should be hard to read. We see not readable and not well-written code often, and sometimes even we press git blame, thinking who has ever written such thing, and we realize it was us a few years ago. This happens, but I think even though this is happening, we have realized, again, as an industry, as a community, that it is super important for the code to be readable. And it's more important than for it to be easy to write, because it is only being written once, but then it is being read many more times and then changed and then read again. And actually, if you think about the API, it's a very similar situation. So the producer team has this API, but it is the consumer team that actually has to live with this API and use it on a daily basis. And it is going to cause issues for them if this API is not usable. So that is why it makes a lot of sense to invite these consumer teams to work with us on our APIs. And it is possible if we are talking about a system with internal APIs. So these are actually colleagues on different teams. And that is why it also makes sense for the consumers to actually drive the creation of these APIs. They will really often have better idea of what they need. And if you ever had such a situation in your life that you were creating both backend and frontend for some functionality, and there was an API in between, if you started with the backend, which did happen to me, you might later go on to developing the front-end part and realize, wow, this API should have been created very differently. It would be so much easier to use. So it is really important to involve the consumers of the API and make them drive the creation of these APIs. However, the problem with the human collaboration is that if there is no appropriate automated process and there are no safeguards in place, things tend to go wrong. So, a potential answer to both of these problems might be consumer-driven contracts. And what are consumer-driven contracts? Let's first think about the contract. A contract is a code that defines that if the consumer sends an input A, let's say, then the producer will respond with an output B. Very similar to the stubs communication that we were defining, for example, while using WireMock. However, the main difference is that the contract should be enforced and it should be guaranteed. So it is not a best effort thing. It is not a wishful thinking thing. The contract means that it is actually guaranteed, and we can use tools and we can use automation in order to guarantee that. And we will see how this can be done with implementation examples in a short moment. And when we are talking about consumer-driven contracts, it is that idea from the previous slides, that it is the consumer that is actually driving the whole process of creation of these contracts and of creation of the API. And we will soon talk step by step what this process may look like. This is not a really new idea. And it often does happen that if a team has some idea and thinks it is very innovative and groundbreaking, and then it looks to the internet, it realizes that it was actually described many years ago on Martin Fowler's blog. And this is what happened when the Spring Cloud contract team was starting to work on it. So actually the idea and the approach has been described quite a long time ago, but since these scenarios where we actually need to use consumer-driven contracts have become more and more popular and apparent recently, actually all the implementations are quite recent. And one of these implementations is this Spring Cloud contract project. So let's see how we can do consumer-driven contracts flow using Spring Cloud contract. So we have these two repositories. We have two teams. We have our consumer team that has this consumer app. So it is sending requests to another app, the producer app. And the consumer team would like something to be added to the API. So they are starting to work on what we call a contract. First of all, some setup will be necessary just to make all this automation work, but it is a very simple setup. As you see, in Maven, we just need to add this Spring Cloud contract Maven plugin, and this has to be done in the producer repo ahead of time, usually by the producer team. And then you just have to pass some quick configuration. You don't even have to add it. There is some default configuration, so if you add nothing, things can still work, but you can very easily change some things here. So as you see in the slide, we have written JUnit 5, so we'll be using it as a test framework. We could also use the older JUnit version. We could use a Spock, and then we can have test mode. So here we are going, it's going to be a Spring application. We will be using web test client with the web flags tools, but we could also be using mock MVC, or we could also be running the testing application in explicit mode, so actually run the app rather than use a mocking framework. And then what we need to define is a tests base class, and we will see the test base class shortly in a code demo. But for now, let's continue with our process. So we have this basic setup in the producer app, and then the consumer team will clone the repository of the producer, and will want to create a pull request for that producer team and propose new endpoint in the API. So in order to propose that endpoint, they will start create a contract. And this is what a Spring Cloud contract looks like. Here it is written in a Groovy DSL, which is super useful because the IDE will be actually suggesting you, as in any normal code writing, what you can select from. So it will be doing the auto-completion for you. And there is also a Kotlin DSL available if you prefer that. In any case, we are using the DSL to define our communication. So we will be sending a request and using the method post at URL fraud check, because we'll be verifying if our customer is valid or if they're a fraud. And in the body, we will be putting a client ID, and we will want it to work with any UID, because we cannot assume that we'll always be getting the same UID in our endpoint. So our endpoint has to handle something that is a valid UID, and that's the input. And then we will also be providing some loan amount. And for this test, we'll be providing this high amount. It's just something that we've set up in demo, obviously could be anything. And if this amount is submitted, then the application should give us certain response. And in this case, we are codifying that. In the response, we will get still status 200, because that's how we want it. We could want a status 500, for example. And then we want to receive a body, and in that body, we want to receive fraud check status field set to fraud and rejection reason set to amount to high. For both sides, we can also add headers. And this is the simplest way to write this contract. So using DSL, I would recommend that. But if you are one of these people that just loves YAML and likes to do YAML development, be my guest. You can write the same exact contract using YAML. So the functionality that this contract provides is same as the previous one. We are just codifying it in YAML. All three ways will work. And we create a pull request to the producer team, asking them to review this contract and tell us what they think. They do their review, and as in any review, they will tell us what we should change. They might discuss with us. So consumer-driven contracts does not assume that that consumer is always right and will impose everything on the producer team. They will drive the things, but the producer team will be able to review and decide on what finally ends up in their code base. So they will review the PR. The collaboration will happen and the contract will be modified if necessary. And then the producer team will run the build on the PR branch, and everything will fail. Why? Because they don't have yet that API. They just have a contract, and the contract is not fulfilled. And we are ensuring that this fails because we are generating tests for that. And this is something that we will see in a demo. But first, let's take a look at that test. So the main way that Spring Cloud contract actually works is it takes a contract, and based on that contract, it auto-generates a test that verifies that our API really does what we have specified in the contract. So we are on the producer side, and an automated test is generated. that is trying to actually reproduce that request from the contract. So it will have the same header, the same body or body matching any criteria that we have put in the contract. We will get a response from our actual producer API, and then we will verify if this response matches all the fields of the contract. So since the producer team has already accepted that PR, so they have assumed that they want to be implementing this API, everything is decided at this point, they need to add the required endpoints. Once they have done this, they can run the build on the PR branch. It is passing. They can merge it, and they can start getting another artifact as well, which is the stub. So first, automated test is generated. And if the test passes, a wire mock stub is generated based on this contract. So we have a stub at the end, but at the same time, we are sure that this stub actually reflects the way this producer app behaves. It is not wishful thinking anymore. One more bonus from using a tool like Spring Cloud Contract is if you see this stub in WireMock in JSON, it does exactly the thing that we have described in our contracts written with DSL. But for a lot of you, and definitely for me, it might be much easier to write it in that DSL than create this JSON from the beginning with all the JSON path specification and matchers. So we end up with this stub. And as we run then we manage all this and we run on the producer side our pipeline, and we get our artifact jar deployed. Alongside the artifact jar, we get another jar, the stubs jar deployed, that contains these stubs. And the consumer can then run integration tests and get these producer stubs downloaded as they would have been downloading any other jar. And in order to leverage this on the consumer side, they actually need to do only very little work. So they need to add this dependency. And I'm showing all these examples with Maven, but it also works with Gradle. So they add this Spring Cloud Starter Contract Stub Runner dependency. And then they get this auto-configure stub runner annotation available. And what they need to do is annotate the integration test with that and pass IDs of the stubs. So our application has the artifact ID, the producer application, SCC producer demo. And we want to get the stubs jar for that. So we write stubs. And then we want these stubs to be launched at port 8080. So it is quite straightforward. And as you see, we use the IV notation. And then the test looks same as if it were run either against any other stubs that were made or as if we were running it against a running producer application. The test just does normal calls and verifies the results. If we don't like to be passing all these IDs in annotation, we can also pass them via properties like here. And also, it is usually not recommended to use a fixed port for test because then you cannot run tests in parallel. So you can also just set 0 as the port number and then use the stub runner port annotation to get the actual port where the application is running. If you're not using Spring, you can still work with Spring Cloud Contract. So even if your application is not a Spring application, if you're not having the Spring Boot test there, you can just use a rule called Stub Runner Rule or a JUnit 5 extension called Stub Runner Extension. And we will again run the stubs for you. So what the stub runner does, either via this annotation or via the rule or extension, is it launches the WireMock underneath and downloads the stubs from your artifact repository or any repository that you have defined in your POM and feeds the stubs to WireMock and makes sure they are exposed and then gives you the port on which to communicate with these stubs. So you can get this import using the find stub URL method. Okay, let's take a look at some code with this. So here is my consumer application, and exactly I'm using, in order for it to be easy to go through, I am using the same contracts that were there in the slides. So it's going to be the same code base, and we will be communicating with the producer app. Here is our producer app. This app has some service, which, as we've seen, if the amount is too high based on some amount that we have defined, we will be getting amount too high result. And I have commented this out just to show you what happens if our API doesn't work. So we have the service, and then we have endpoints, and we could have just usual endpoints, so usual Spring Web Flux controllers or Web MVC controllers with annotations, but just to make it a bit more interesting, I have used the functional approach to creating endpoints in Spring. In case anyone doesn't know, you can do it this way instead of just creating controller annotated classes. So we have this router function that we have created, and we are using this handler in the router function. And what this handler will do is just call this verify method that we have seen. So this is our endpoint. This is what it's supposed to be doing. And on the consumer side, we are actually collaborating with this app. So we will be doing calls to that endpoint. And we have a fraud check request that we will be sending. And let me show you the app code. Okay. So here we will be doing a call to that service that should be running, we assume, on 8080 at the fraud check endpoint using this method. So it is called loan application. And then in our test, what we are going to do is call this loan application method that should trigger HTTP requests going to that fraud check application, endpoint fraud check port 8080, which is not running. It is just there. We have the code, but it's not running. So we have these tests, and obviously nothing is running now. If we just run it, they will fail because no call can be made. Yeah, so that's something to be expected. And now let's see how we could use contracts and stubs. Let's go back to our producer application, and let's see the contract. So this is the contract that we have seen on slides. And first, let's see our build setup. We have added the plugin as we discussed, and we have this base class for tests. So what the base class for tests does is to just set up the endpoints that will be tested. So the easiest way to do it is to use rest assured either with mock MVC or with web test client, and just pass the controller or the routing config to it. And what it will do is just launch the controller alone, just with some necessary backing. So usually the service that will be required for business function. Although for the contract test, we would even suggest that instead of doing this, I'm just doing it because it's super simple, it's demo code, but usually would suggest to just stop this service, whatever it does, because what we want to verify with contract test is the API, not the functionality itself. The functionality of this service should be verified in some lower level tests. So we just want to launch this controller using rest assured, and it is, as you see, just usually one line where you pass a service or some stub mocked service. So this is the base class, and the base class will be used by all the auto-generated tests. So they all will extend this class. And we have also added contracts. So we added contract under source test resources contracts. And in this case, we have them in Groovy. We could also have them in YAML, as we've seen. We have a fraud scenario here and a non-fraud scenario where we want to have the status 200 and fraud check status okay. So we have added these contracts, but as you've seen, I've commented this out, so it doesn't work. Our API does not work this way. We'll not get the right response. And let's see what happens if we run it. It obviously fails because we don't have the right implementation. So the test, contract verifier test, fails. And where is this contract test? If you see, these are the only tests we have. There is some standard Spring Boot test, and there's the base class, which is not even an actual test. It doesn't have any test annotated method. But the framework has created for us this test called contract verifier test. And as we've seen in the slides, what it does, it just translates the contract into actual verification. So we have not done anything. This has been done for us, and it verifies that our app actually does what we define in the contract. So let's fix it in such a way that it will be true. And let's rerun it. Okay, and what we can see in the log, that apart from the artifact, the jar that was installed of our app, another jar was installed with the stubs qualifier. These are our stubs. And now we have just built this up. We are not running it. If we go back to consumer and we run these tests, they should be able to use these stubs. And as you have seen, this works. And we can even see exactly in the logs that stubs definitions were matched by WireMock, and appropriate response has been set for the request that we received because they match whatever request definition we have put. So we get the response that we expect. And in this way, we have fast stub tests, but at the same time, we are sure they verify something and not just not our wish. And we could also use Spring Cloud Contract for messaging. So in the interest of time, I will not be demoing it, but I will just show you the contract on the slides. We usually have either an input message that should trigger an output message, or like here, for example, a method is called and that should trigger a certain output message. So in this case, if the method make successful payment is triggered, then an output message should be sent to payments topic or channel and should have certain body that we describe here and headers. And we get a contract generated test that verifies all this exactly same as in the case of HTTP communication. So it's trying to actually trigger that method and make sure that there is a message that is generated. And then on the consumer side, we get this stub trigger interface, which we can use to trigger this interaction. So we use the label. If you go back, you see that there is a label here saying payment successful. And then we can use the stub trigger with that label to get the message sent to us. And these were the main features. And actually, I think what I've shown you is the core of the functionality that we provide, but there are also some other interesting features that you might want to know about. So if you cannot be using the repositories of other applications in your company, this is one of the questions we often get because of security reasons. It is possible to just keep contracts in a separate repository, not with the producer app. We also provide integration for Spring Cloud Netflix and Spring Cloud Load Balancer. Also, if you are using Spring REST docs, you can create Spring REST docs from contracts, but also contracts from Spring REST docs. So if you use any one of these integrations, you are getting the other one practically for free. We also offer polyglot support. So we have a Docker image that we provide, and you can download it, that has the Java app that does it all for you. So can verify another application by generating tests there, or can run wiremock and stubs. And if you're working with someone that is not a Java developer, for example, backend you have in Java, but you are working with front-end team that is just using JavaScript, and they wouldn't want to do it on their machine and run this application with Spring Cloud Contract, you can just provide them with a Docker image, and the stubs will be loaded for them without them having to do practically anything. We also offer community support for Swagger files, where you can keep the contract in the same place as you have your Swagger definitions. Contracts have also some interesting implications on the level of architecture and deployments. So first of all, something that is great is that we are actually moving the TDD approach to the architecture level, because we have first this situation where we have a contract but no API, so the tests are failing, it's red. Then we are adding the actual implementation, we have our test green. But then as we go working on our contract and on our API, we also have a method to test that things still work and that our integration with our consumers still works very easily. Also, we can use Spring Cloud Contract to verify compatibility of APIs in our pipelines. So a lot of times, I think this is something recommendable. So a lot of teams would always want their APIs to be backwards compatible. And we obviously don't want to upload a new version of the API and have apps running in production break because they were expecting some different endpoint to be there that was removed. And we all try to create our applications and change our APIs in this way. However, we don't often test that it is the case. And with tools such as Spring Cloud Contract, you can add it to your deployment pipeline. Simply what you do is in your pipeline, have a step where you run against the new contract. So you get the build with the generated test from the new contract, but then in another test, you take the other contracts that are currently in production and you run it against those contracts. And if it passes also against those contracts, it is backwards compatible and you can deploy. And what do we do if we want to change something in the API? Because as we've said, usually internal APIs, we want them to be backwards compatible, not to break anybody, but it doesn't mean that we don't ever want to change them. So we usually use the deferred updates approach, similarly as we do with databases. So there also, if we want to modify something, we use this approach. And what we do in the case of API is, let's say we have a field where we had build time in seconds. And at some point, we decided that the build time should actually be expressed in milliseconds. So in the contract, we add this field. We still keep the old field, but they add it with the new field in milliseconds. And then in the application, we also have the old field and then the new field. And then after some time, we remove the old field from the contract. And we still have it in the application, but as they keep running their tests, as they're working on new version, they realize as we are going to deploy our new version, we need to adjust because the field is no longer in the contract. So then they adjust them, and then our production app can be also deployed with only the new field, because our consumers have already realized, based on the contract, that it is missing, it is not there. Their applications were not breaking in production because at the time it was still there. We just removed the field from the contract. But then as their test failed, they knew that any new version that they release must use the different field. And then our change is done. Some lessons learned when it comes to working with contracts. So before I was working on the team that developed Spring Cloud Contract, I also worked somewhere where we just used Spring Cloud Contract. And we have had some time to understand some best practices and good approaches. The first and main thing is the logic level tests should be done in lower layers. The contract tests are there to verify our API. It is very tempting with the possibilities that the contracts provide to try to write something which would be a contract test, but would really do what an end-to-end test does. So to verify all the business logic and the various business scenarios using contract tests. This is a bad idea because this will cause us to get a lot of maintenance issues over time. We want to use the contract to verify the API. We want to use the lower level tests to verify the business functionality. Then as we switch to having less end-to-end tests and more contracts, we still need to take care of other ways of ensuring everything is working fine. So to make sure there is monitoring, logging, alerting in place, and our applications can be resilient. Also, in order to make the maintenance easier, we can skip contracts for non-essential functionalities. And this depends on your APIs, how big they are, how big the teams are. So maybe you don't have lots of endpoints, you have some concise APIs, and you just use contracts because it's easier to collaborate in this way. And then you just prefer to have everything in the contracts. But sometimes you have very robust APIs. And if you have an endpoint that doesn't do anything that is business critical, like it's very rarely used, and your company has earned $1 on that functionality in all year, maybe you don't want to be maintaining contracts for that endpoint. Also, you can skip multiple values because, again, you are not trying to test the logic, only the way the API behaves and let's say the headers and the fields in the body and the deserialization and the endpoint is right and so on. So you don't want to be testing all possible scenarios. So if we send string A in the body, we should receive this. If we send string B in the body, we should receive this, and so on. And this is more or less what I have prepared for today. I am also adding the links for you with the project page where you can find all the information and the links to GitHub. Also, I'm linking the demo projects that I've been showing today. There is also a link to a samples repository that has a lot of samples for very different scenarios, and a link that describes how to use a Spring Cloud contract with Docker, and also a case study link, and link to Spring Cloud Pipelines article that describes how to use this backwards compatibility API test, among other practices that you could use in your deployment pipelines. Thank you very much. We could now do questions if there are any.
Yeah, thanks a lot, Olga. That's a very interesting session, especially around giving consumers more control around how they define the API contract and stuff like that. Having led development teams myself, I know, how not having mutually agreed contracts sort of breaks things on production. So, I mean, this is like a really, really enlightening session in that sense. So we have a couple of questions, but considering we're doing we have very little time, we'll just prioritize two. So I've got George Nicolay here asking, what if the producer side cannot create those stubs? Can we do something to make reliable tests and record requests? So so that's a question that's on the chat. So if you could take that question.
Yeah, sure. So I'm not sure I understand correctly, because if we do have contract approach, we will get the reliable tests and stubs. Mm-hmm. So as long as we do add the contract, we can be sure. So maybe that's about this first part of the presentation. where I was just talking about using stubs alone. So if you use the stubs alone, they don't give you any assurance. But if you use the stubs with a tool like Spring Cloud Contract and you use the contracts, these stubs are very reliable.
Got it. Got it. And so running these tests in a CI/CD pipeline as opposed to running them locally, so how does it differ? So I think that's an easy question to answer, right? So
Well, I would do both. So I would run them locally when I work on it and I want to be adding the endpoints and I want to make sure my project is building. And then I would definitely have them running in the deployment pipeline to make sure nothing has been broken. So it is useful locally for local development while you're working. And then it is absolutely necessary in a deployment pipeline to ensure that this really works and nothing has been broken in between.
got it. Yeah. Yeah. So thanks a lot, Olga. And then, the resources that you pointed us to are really, interesting, and especially the code samples and stuff like that. So we'd have the, participants go look at it. And just to, mention, version of this webinar, recording of this webinar will be uploaded on our site. So for people who couldn't join this webinar to view it later. So thanks a lot for your time. We really enjoyed having you on this webinar today.
Thank you very much.
Thank you. Bye-bye.